students, welcome to our physics class. Our chapter name is gravitation. In the last classes, we discussed about different topics in this chapter. And in the first day, we derived the universal law of gravitation. F is equal to G m by d square. We derived this equation. And what is this d, m and this small m? Capital M is the mass of the object, the small m is the mass of another object, and d is what? The distance between these two objects. So, and this F is the force of attraction between these two objects that we studied in the first day. Then we discussed about certain type of acceleration, that is, when an object is getting attracted towards the earth, then this object is having certain acceleration. And that acceleration we call it as g, and that is acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity. And then we said that how we found the value of g. G is equal to gm by r square. Gm by r square. Here what is the gm and this r square? This g is the universal law of gravitation. This m is the mass of the earth and this r is the radius of earth. That means these three are constant, and when we give values to this, we get the g is equal to 9.8 meter per second square. These are the things we discussed in the last class. Now we are going to the further topics, and according to this, g is equal to 9.8 meter per second. That means that all the objects are coming towards the earth will be in same acceleration, or simply we can say it is coming with same speed. And now I will show you something that have difference with this. That is, this is the surface of earth, and one building is here, and a person standing at the top of this building, and he is dropping one piece of paper and a stone from this height. That is a paper and stone. Now my question is, which one will come to down at first? Do both of the things will come at the same time? That means we said that g is equal to 9.8 meter per second square. That means the object, any object will come towards earth with an acceleration of 9.8 meter per second square. But what happens here? What is the case? Here the stone will come faster than this paper, and the paper will come very slow. Then how we can connect these two? What is the reason? There is a reason, and we are going to discuss that. So here they have a time variation. That means they are reaching at the surface of earth at different time. And also we can say that they are having different acceleration. That is the meaning of that. And actually why? The reason is this. What is here? Here we have atmosphere, and in the atmosphere they have air. And this air is having resistance, and that resistance causes this difference. So now we are conducting another experiment with a setup creating vacuum in a jar. Vacuum means we are just eliminating air inside the beaker. Experiment is like this. We are keeping the paper and stone at a particular point, and we are just taking out all the air. That means no air inside this beaker. No air. And we are observing what happens. When you observe, you can see that both of the things are coming at the same time. That means the acceleration of both of the things are same. That acceleration is 9.8 meter per second square. So, this is the thing. Actually, this experiment was first observed by Newton. The experiment was first conducted by Newton. And the experiment name is like this: feather and coin experiment. Feather and coin experiment. Actually, the concept was first argued by the scientist Galileo. But the problem was this: he was unable to create vacuum. That means Galileo was unable to create a system without air. At his time, it is unable with the setup. But later, Newton made such a setup without air and conducted this experiment. That means the experiment setup is like this: a long glass tube. One more long glass tube. This glass tube contains air. That is, it is filled with air, and this glass tube have no air. That means it is the state of vacuum. And in this, we are keeping feather and a coin. And here also we are keeping feather and a coin. And then we are just leaving this, then both of the things will come down. And when you observe, we can see that in this, that means the air with the tube, you can see that the coin will move very fast than this feather, because the coin is having less resistance with the air, but the feather is having more resistance with the air. And the same thing is with the paper piece and the stone. For the paper piece, it is having more resistance than the stone piece. And what here happens is that here no air, so both of the things are moving at the same speed. That means same acceleration. And that acceleration is 9.8 meter per second square. So actually here the difference occurs because of the air and air's resistance. Here there is no air and so no resistance. And because of that, these things are coming at the same acceleration. So we are concluding this as, when we are negligibly avoiding the resistance of air and all, then all the objects will come towards Earth with an acceleration of 9.8 meter per second square. Even if it's elephant or ant, there is no relation with the mass. No relation with the mass. So that's why always the object will come with the acceleration 9.8 and we call it as g. Even if it is a massive body, very tiny particle, or even if it's a hollow body, the same will happen. So this is all about this. In the last chapter, we studied about the equations of motion. 3 equations we studied. Equations of motion. Which are the equations? V is equal to u plus at. Then the second equation is this: s is equal to ut plus half at square. And the third equation is this: b square minus u square is equal to 2a. Yes, these are the 3 equations of motion. Now you can see here a in this equation, here also a in the equation, and here also a in the equation. What is this a? A is the acceleration. Now in this chapter, in this gravitation chapter, I am going to replace this a with g, acceleration due to gravity. That is the equation will be now like this. V is equal to U plus GT. First equation. The second one is like this. S is equal to UT plus half GT square. And the third equation is like this. V square minus U square is equal to 2GS. Here, no difference is there. We are just giving this A as G. Both are acceleration, but here it have the perfect value 9.8 meter per second square. And in some problems they will give, you can take the value as 10. Then you can proceed this with 10. Otherwise you want to take the value 9.8. Now next we are going to do one problem. And the question you can see in your textbook. The question is there in the page number 136, example 10.2. Example 10.2. That now I am going to explain. The question is like this. A car falls off a ledge. That means a ledge is there and a car is at this point. A car falls off a ledge and drops to the ground in 0.5 seconds. That means this car is coming to down and reach at this ground with a time of 0.5 seconds. And here they just gave the value of G is equal to 10 meter per second square. And in this first question is like this. What is its speed on striking the ground? That means, what is the speed of the car when it hit on the ground? That is the question. So, we want to find, in the question they just gave it as speed, but actually we want to find the velocity. So, in this question, they do not mention the initial velocity. Actually, at the point when this car starts to fall down, it is at rest. So, we are taking this U is equal to 0 meter per second. And then, we want to find the final velocity. That means, when this car is getting to ground, what is the final velocity of this object? So, we want to find the V, and we have G, and also in the question they just gave the T. So, which equation we will select? We want to select the equation V is equal to U plus AT. Here we have G, so I am just writing it as U plus GT. Then substitute the values. 0 plus 10 into this time is equal to 0.5. So this is have got, then the final value is 10 into 0.5 and you will get the answer as 5 meter per second. Meter per second means we are finding the velocity. So the unit is meter per second. This is the answer for the first part. The second question is this. What is its average speed during the fall? That means what is the average speed in this process? So how we can find the average speed? The equation for average speed is this. Average speed is equal to V plus U by 2. This V is the final velocity, this U is the initial velocity, and we are finding the average, so we are dividing these two with that number of the base 2. And if we want to find the average of three things, I am just generalizing. A plus B plus C, we are adding these three and divide by 3. If we are finding the average of particular thing of 4 things, A, B, C, D, then we are adding this and we will divide it by 4. So that's why the 2 K. So our equation is this. The average speed is V plus U by T. The V is here, we solved in the part A. And the U we already know, gave in the question. So we can write 5 plus 0 by 2. What What is the answer? The answer is 2.5 meter per second. This is the average speed during this fall. Now, there is also a third part. This is the second part and the third part. The question is this: how high is the ledge from the ground? That means we want to find the height. That means the S. What is the equation for finding this S? S is equal to ut plus half gt square. S is equal to ut plus half gt square. Here we know u, t, g and t. So we just want to substitute the values and find the answer. Now I am going to substitute the values. U is what? 0. 0 into this time is equal to 0.5. So here is 0 and this term will cut out. Plus half into this g is equal to 10. 10 into time square, that is 0.5 square. So I can write it as I am just multiplying these two. That is 5 into 0.5 whole square. 5 into 0.25. When squaring this, we get this value, and when we multiply, we get 1.25 meter. This is the answer. That means this is the height of the ledge where the car falls to ground. 1.25 meter. This is the explanation for that 10.2 example. Now, there is also one more example, that is 10.3 in the same page number 136. Next we are going to explain this. 10.3. The question is like this: an object is thrown vertically upward. An object is thrown vertically upward and rises to a height of 10 meter. Calculate the velocity with which the object was thrown upward. That means we want to find the velocity. What velocity? Initial velocity. We want to find the initial velocity. And the second question is this: the time taken by the object to reach the height point. That means we want to find the t to attain the height 10 meter. These are the things we want to find here. And one more thing. From the question, we want to identify certain values. One is this height. That is the S. S is equal to 10 meter. That it is there in the question direct. Now, we want to find the U, but we can find the V using the question. That means when this rock is thrown, at this point, this rock is at rest. So, we can take this V is equal to 0 meter per second. And we know the value of G. They don't give the value as 10. So, we want to take it as 9.8 meter per second. And also, there is one thing. What is this 9.8? That is the inward pull towards the earth. So, what is the acceleration towards the top? The stone is going upward. So, generally, when stone or anything that will come down, we are taking the value as 9.8 meter per second square. Positive. And when the stone or object is going upward, we are taking it as minus 9.8 meter per second square. The direction is, we are representing it positive and negative. For the positive, we are not writing this. So, when this is going upward, we are taking minus 9.8 meter per second square. So, here the acceleration A is equal to minus 9.8 meter per second square. So, these are the values. Now we are going to solve this. First we want to find the u. Which equation we select? We select the equation v square minus u square is equal to 2as. V square minus u square is equal to 2as. So, we want to find this u and all other values we know. So, we want to substitute this. V square is equal to 0 square minus u square is equal to 2 into minus 9.8 into this s. S is what? 10. So, this 0 is here. So, it is gone. Now, minus u square is equal to 2 into 10. 20 into minus 9.8. So, the same thing, I am just writing this 20 this side into 20. Both are same. Now, this negative and this negative, and here is multiplication, so we can avoid this negative, and so we can write it as u square is equal to 9.8 into 20. So, when we multiply this, we get the value as 196. 196. And so, here this 196 is what? U square. We want to find the u. So, u is equal to square root of 196. And the answer is this 14. We are finding the velocity meter per second. So, this is the answer, 14 meter per second. So, first part is over. And the second question is, we want to find the time. How we can find the time? For that, we are selecting the equation v is equal to u plus at. v is equal to u plus at. And we want to find this t. So, this v is what? 0. 0 is equal to this u. We already found. It is 14 in the part A. 14 plus, what is this a? That is minus 9.8. Here we all are talking about the stone is going upward. That's why we are taking minus 9.8 into this time. That we want to find. So, first of all, I am taking this plus 14 to this side. So, 14 will be turned into minus 14 is equal to minus 9.8t. That means here this is multiplication. Now, what happens when we just take this minus 9.8 to this side? It will turn into division. So, minus 14 divided by minus 9.8 is equal to the time t. So, we can cancel out the both of the negative. Then final we get the value as, when we divide this, we get the value as 1.43 second is equal to the time. This is the answer for this question. I hope it's clear. This is all about this area. Acceleration due to gravity and the problems. These problems are important and you want to study this, and more questions are available in the exercise part. Now we are moving to the next topic, that is mass and the weight. Mass and the weight. What is this mass and what is this weight? Do both of the things are same? We are using these simultaneously, all the spaces, but what is this mass and what is this weight? How we can define this? In the last chapter, we studied this mass and the relation with the inertia. How we studied that? We said that mass is directly proportional to inertia. That means When the mass is higher, then the inertia will be also higher. When the mass is less, then the inertia will be also less. We studied this. Now the question is how we can define this mass. What is this mass? We can explain this mass as the measure of matter. Mass is the measure of matter in the body. In the body. Measure of matter. That means when a body is this, it is the measure of matter that included in that body is what? Mass. That is the matter we already said. Now the question is what is this weight? How we can define this? And what is the difference between this mass and the weight? Now we are going to discuss that. For that, I am considering Earth is here, Moon is here, Saturn is here. Earth, Moon and Saturn. And a person is standing. The same person is standing at the surface. This is Moon, this is Earth and this is the Saturn. So, the same person is standing at the surface of Saturn. And now first of all I am going to find the mass. I am just assuming some value. So, when I am observing the mass is equal to here 10 kg. And then the same person is going to Moon and find the mass. Then get it as m is equal to 10 kg. Same 10 kg. And again the same person is going to Saturn and measuring the mass. Then it gets as m is equal to 10 kg. That means with all the Earth, mass and the Saturn, the mass is same. The same mass. That means this mass is a constant. It is not depending upon the surface and the attraction. That is what the matter included in the substance. So it is a constant. But what about the weight? It is not actually something like this constant. It is getting varied with the surface. That means when we are finding the weight of this person at this Earth, it is having a particular value. And when we are moving to Moon, then again the weight is having another value. And when we are moving to Saturn, here also it is having another value. Why? That is because we are going to explain. What is the equation for this weight? The equation for weight is we are going to derive. First of all, what is the Newton's second law? F is equal to mass into acceleration. Now I am going to connect this with here. This is our Earth and here a person is standing. This person have one attractive force towards the Earth and he is having the acceleration of 9.8. That means I can write this as m into g. So this m is what? Mass of this person. So this is a type of force that the product of the mass and the acceleration due to gravity is what? This force, and I am calling this force as W. That W is weight. We are denoting this W with capital W. So this W is equal to mg. This is the equation for finding weight. Mass into acceleration due to gravity. That means how we can define this weight? We can define it as weight of an object is the force. We already said that. It is the force that is attracted towards the center of Earth. Earth. When we are moving to Moon, it is having another value of g, and so there we get another value of weight. And when we are moving to Saturn, it is also having another value of g. This is what actually we measured or calculated by using the mass of Earth, the radius of Earth, and the universal gravitational constant. So this g depends upon the radius of this Earth and the mass of the Earth. So when we are talking about the Moon, it is something smaller than this Earth, and so its radius is different and also the mass is also less. That is because the weight is getting different at different planets and all. So we can say that the weight is what? It is a type of force that is attracted towards the Earth. Or we can say the attraction of Earth on a particular object. And this is the equation. Now the question is, what is the unit of this weight? The unit of weight is what? Newton. The same unit for the force. The force and the weight having the same unit, that is the Newton, and we are representing it by capital N, Newton. So this is all about this. And one more question is the, do this weight is scalar or vector? Scalar or vector? Actually, this weight is what? We are saying that for the Earth, it is attracting towards the Earth. So here it have direction. So obviously we can say this weight is vector, not the scalar. Because for this weight it is having magnitude and also the direction. So we can say this weight is what? Vector quantity. This is all about this. Now we are going to do one mathematical problem with this simple equation. The question is like this. The question is also available in your textbook, and the question is there in the page number 138, 10.4. Example 10.4. The question is this. Mass of an object is 10 kilogram. What is the weight on Earth? What is the weight on Earth? This is the question. What is our equation? W is equal to mg. W is equal to mg. So mass is 10 and what is the g in Earth? It is 9.8. So this we get 98 Newton. This is the weight of the object. Now, the next thing we are going to discuss is the weight of object on Moon. I already said that the weight is different at the surface of Earth and also at the surface of Moon. The first reason is this. Our Earth is bigger than Moon, and also here the radius is different. I am just taking this as RE, and here the radius is RM, the radius of Moon and radius of Earth. And here the mass of Earth is, I am taking ME, and here the mass of Moon I am taking MM. So just put these values in mind, and we are now going to find the value of weight of an object at the surface of Moon. So for the Moon, the value of attraction is less because the mass for Earth is higher than Moon. And now we are going to represent it using one equation and find the relation between the mass of Earth and the mass of Moon and the gravitational acceleration. That means, what is the equation for the universal law of gravitation? F is equal to G m by d square. And here we are talking about the radius of this, and I am just replacing this d square by r square. First, I am going to write the force of attraction. This F means W. That means I am first going to write the equation for the weight on earth, and then I will write the equation for the weight on moon. Then I will divide these two, and finally I will get a particular value. So this WE, that is the weight on earth, I am going to write it as this G is the universal law of gravitation. So that is a constant. It is unable to change. So we are writing it as like that. Now this is M, mass. What mass? Mass of the earth. And what is this M? This is the mass of the object. That means we are talking, this is the earth, there is having one object. So this small m is the mass of this object at the surface of earth. And this r means radius of earth square. So this is the equation A. And then the next one is Wm, weight of the object at the surface of moon. Now this is moon and this object is at the surface of moon. So we can write it as Wm is equal to, again this G is the universal law of gravitation, that is a constant. We are unable to change, so we are writing it like that. And then we are writing M, mass of the moon into M. This is the mass of the substance. We are talking about the same object at the surface of earth and at the surface of moon. So I am writing that M in the similar way. And here the radius of moon square. This is the equation B. Now I am going to do that. My aim is to find the ratio of this, the weight of the substance at the surface of moon and at the surface of earth. That means I am just dividing this Wm divided by We. So that is equal to, first of all I am going to write this. Just observe. G capital M suffix M small m divided by Rm square whole divided by, I am putting these all things here. That means G, M and this is E into M whole divided by, here also one thing, that is what? Re square. So here what is this? G M E M by Re square. That is the division. So using simple mathematical step, how I can write? I am going to replace this as multiplication. Then what I have to do? I just want to take the reciprocal of this component. So I can write it as Wm by We is equal to G capital M small m, that is this m is suffix small m divided by Rm square into, now this component I am going to write it as multiplication. This bottom part will be here. Re square divided by this Gmem. Gmem. Now you can see some things are similar and we can cut this. This G and G can cut off, and this M and M, we are talking about the mass of same object, so we can cut off. So what is now here left? M Re square by Rm square Me. This is what? Wm by We. This is the thing. And here you can see mm means mass of the moon. This Re is what? The radius of earth square. And here Rm means the radius of moon square and Me is the mass of earth. Now these all things are constant values, and now we are going to substitute the values for this. I think all these steps are clear for you. Now I am going to substitute the values. The values are like this. Mass of the moon is 7.36 into 10 raised to 22 into. Now I am going to substitute the radius of Earth. 6.37 into 10 raised to 6. This we want to square. So we want to give the square symbol there, and divided by RM square, radius of moon's square. So it is 1.74 into 10 raised to 6 all square. This square is this, into, what is this? Mass of the Earth, that is 5.98 into 10 raised to 24. So here you can see number of powers are there. That means here 10 raised to 6 square, and here also 10 raised to 6 square. So we can cancel this component here and here. So, and you can see here the 10 raised to 22 and here 10 raised to 24. That means we can cut these two, and then here only 10 raised to 2 will left. So the equation now is like this: 7.36 into 6.37 into, not into, 6.37 square divided by 1.74 square into 5.98 into this lefting 10 square. So now we just want to multiply these values. After multiplying, you get the answer as 0.164. 0.164. So what is this? This is the ratio, that is, this is equal to Wm by We. That is, I can write this Wm by We is equal to this 0.164. I am going to write it as a fractional form, and this is equal to 1 by 6. So we can say it as the weight of an object in moon is equal to 1 by 6th of weight on Earth. You can use either the small letter E or capital letter E, no problem. So this is the ratio of the weight of an object at the surface of moon and at the surface of Earth. That means, I will show you the example. One object is there at the surface of Earth. That means a person is there, and his weight is 60 Newton. His weight is 60 Newton. And this person is going to moon, and then when he observes his weight, then only what is the value? We want to divide this 60 by 6. That is the meaning of this equation. So then the same person is having different weight at Earth and moon. This person is only having 10 Newton at moon, and at Earth it is 60 Newton. This is about the weight. So we are actually at the end of the chapter. Now there is a small problem there. This is also in your textbook, the question. And the question is this at the example 10.5. At the same page, the question is this: an object of weight 10 Newton at Earth. And what is the weight at moon? That is the question. What is our equation? Wm is equal to 1 by 6 We. So this 10 is what? We. So how we can find Wm is equal to 1 by 6 into this 10. That means we are dividing this 10 by 6, and so our value is 1 1.67. When you divide this, you get the answer as 1.67 Newton. So, when an object is having 10 Newton at Earth, it is only having 1.67 at Moon. And you can also do some extra problems at the exercise part. Now, you want to do problems in the exercise part in the textbook. Actually, we concluded the chapter. You just take the textbook. You can see some sort of types like the thrust and pressure, then the pressure in fluids, buoyancy, and the Archimedes principle, like the things. It is now in the syllabus now. They are just cut off. So now no need of studying these topics. That means the thing I just mentioned at the page number 138, the thrust and pressure, and till the end of this chapter. Archimedes principle, the relative density, all these things are cut off. So our chapter is over and now you completed this class. So you want to do the mathematical problems till 10. The number 10, and that is in the page number 144. Here we have number of questions are there around 18 and the further 4 is in the cutout area. So the further 8 we will do in the coming classes. So you want to do these 10 questions as homework and you want to submit it before Monday. So this is all about today's class and our chapter is over. And we will meet in the next class with the next chapter. Thank you.